Today we'll be going over LeetCode problem 213, House Robber 2. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we're going to imagine that we are a professional robber, and we want to rob a certain amount of houses along a road. What we want to do is return the maximum amount of money that we can rob from these houses. However, we must keep in mind two rules. One is that we cannot rob two adjacent houses, and a second one is that these houses are arranged in a circle. Now, the second rule is the only difference between House Robber 1, which is another problem I solved on my channel, and this problem, House Robber 2. Because the houses are arranged in a circle, this means we cannot rob both the first and the last house in our array. So we have this nums array, and this nums array represents the houses and the amount of dollars each of the houses has. The first house has $2, the second house has $3, and the third house has $2. I have drawn another example here to the right, and we have a nums array with 4 houses, and each of which containing a different amount of dollars. Now we're going to go through the solution that we used for House Robber 1, because this solution for this problem is actually just going to be a tweak to that algorithm we already learned during House Robber 1. So again, we're going to use dynamic programming, which will allow us to solve the problem in a linear time complexity, as well as a constant space complexity. Now we're going to look at this array, and we want to take into consideration the 2 possible paths we can go through, because this will allow us to break the problem into smaller subproblems, which we could then reuse in order to solve our bigger, larger problem. So we know that when starting from the first house, we have 2 options. We can either decide to rob the house, and therefore we would take the $1, and in that case we would have to skip the next house because these 2 are adjacent and we cannot rob 2 adjacent houses. And then we would go on to find the max that we could add to this $1 that we robbed by going from this part of the array all the way to the end, having skipped the second house. Our second option instead would be to skip this first house. And so what we would do is go and find the maximum amount we can rob starting from this second house. And we see over here at the bottom, I have basically wrote out this recurrence relationship. So we have our first case, which I underlined in red, where we rob house 0, and then go on to find the max from robbing from house 2 all the way to the end. And then our second case, where instead we skip the house at index 0, and we find the max that we can rob between house 1 till the end. And what we're doing is basically finding the max between these 2 cases and returning that as our solution. Now, both of these 2 subproblems here, when we go from the second house to the end and from the first house to the end, can be similarly broken into smaller subproblems, just like we broke down this problem for the entire array. And because of this, we can use dynamic programming. So now we're going to see what we're going to do while moving along the array. We're going to start from the first index, index 0. And at each point, what we want to do is find the maximum amount we can rob possible up until this point. Now, if we're only considering this one, we know that we can either rob it or not. And since we're not looking at the future, we would rather rob this house. And so up until this point, our max would be 1. Then we'd move on to the next index. Now we say we have a house with $2. So our option would be either to rob this house with $2 or rob the house with $1, which we have the value here. But we cannot rob them both because they're adjacent. So of course, at this point, up until this point, we would decide to rob this second house with $2. Then we move on to index 3. Again, we have 2 options. We can either rob this house, and if we do, we can go and add the $1 from 2 positions ago, or we can decide to skip this house and take the preceding value. However, we cannot take this preceding value if we decide to rob house 3 because these 2 are adjacent. So of course, because 3 plus 1 is 4 and that is greater than 2, we'd rather rob house 3 plus the first house and get a sum of 4. Then we would move on to our last index in our array. So again, what we did in house robber 1 is we would consider if we want to rob this house, and therefore we would be able to add the 2 from 2 positions before, or if we want to skip this house and instead take the preceding value. However, once again, we cannot rob both the preceding value and this current one because they are adjacent. So we'd rather take this 4 because it is greater than 2 plus 1, which is 3, and so we'd have 4 as our max value. Now this is exactly how we solved house robber 1, and we know that because in each case we are analyzing our current value and comparing it with the values which come preceding it and 2 houses prior, we only needed 3 pointers, rob1, rob2, and cur. We would solve the solution for the current value, which depends on rob1 and rob2 each time, and then we'd move our pointers along to find the next values. Now, for this case, however, in house robber 2, we need to consider one extra thing, and this will be a small change to our algorithm. In fact, we are told that these houses are arranged along a circle. And because of this, we know that the only difference is that we cannot rob both the first house and the last house. Because if they're arranged along a circle, the first and the last house are actually neighbors. Consider this a circle, and this is the first house, and this is the last house. So what we're going to do is basically run this algorithm from house robber 1 twice, and the first time we will run it starting from index 0 up until the second to last position, and the second time we're going to run this algorithm starting from index 1 and going along until the last position. In this case, in our 2 algorithms, we're not taking into consideration both the first index and the last index at the same time. So we do not interfere with this rule. And after having run this algorithm twice, we would basically just return the maximum value that we obtain each time between both the times that we run the algorithm. So because we're just running our algorithm twice, it remains O of n, and we're still using the 3 pointers, so it's constant in space complexity. But we just have a small change from our house robber 1 algorithm, and I'll show you this in the code. We're going to start off our code by taking care of an edge case. We know that if our length of nums, the nums array, which represents the houses, is 1, this means that we only have one singular house, and so we want to rob that singular house, because it's the only one we can possibly rob, so we're going to return nums of 0. Now what we said we're going to do is basically run the algorithm from house robber 1 twice, and each time we're going to get a different value. The first time we want to run the algorithm, which we're going to call findMaxRob, and we'll define this function later. And we want to run it by taking our array, starting from index 0, and going to our second to last position in our array. So I'm going to put here as the endpoint length of nums minus 1, because we know that this second parameter is non-inclusive. And then our second value, max2, is going to be taken by running the same algorithm, but this time going from the first index up until the end of the array, so length of nums. And what we want to do at the end is return the max value between these 2 cases. Now we need to define our findMaxRob function. So we're going to define this function, and it's going to take in our array, which is going to be different in the 2 cases. And initially we can define our rob1 and rob2 pointers, which will be initialized to 0. And remember, our timeline goes like this, where we have first rob1, rob2, and then our current value. And then for each number in the array, we want to calculate our current value, which is going to be depending on our 2 cases. One where we rob the current house, and then add that to the max value we had up until 2 houses prior, so rob1. Or we can decide to skip the current house and keep the value from the previous adjacent house, which is rob2. And then we want to move our pointers. So rob1 is going to be rob2 is going to be the cur, or the current value, and then at the end of our function, we can just simply return rob2. Or we could also just return the current value, because we know at this point, rob2 and cur will be the same. So let's make sure this runs, and we see that it works. Thank you so much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.